This is question number 17 from chapter 2.4. It gives us a piecewise function and it wants us to check to see if the slope is defined at x equals 2. So the piecewise function from the left up until and equal to 2 is defined by 1 over x. And from the right is defined by 4 minus x over 4. And all the way from the right up until but not equal to 2. So the first thing I did was just simplify that linear expression. So 4 minus x over 4 became y equals 1 over 4x plus 1. So I've got a slope of negative 1 over 4 and a y-intercept of plus 1. So I want to know if the slope is defined at that point. Well, the first thing I have to do is actually check for continuity. Okay, so I've written that down here. We have to always check for continuity first, because if it's discontinuous, we cannot define slope at endpoints. So I'm going to do that. I'm just going to check for continuity. I'm just going to do an informal check by plugging in, okay, from the right, this is equal to 1/2 when I plug in the 2. Sorry, from the left, and from the right, using the pink function, I'm going to plug in 4 minus 2 over 4. Again, that simplifies to 1/2. So this is continuous, okay? So if I were to write it formally, it looks like this. The limit as x approaches 2 from the positive side of f of x is equal to 1/2. And the limit as x approaches 2 from the negative side of f of x is equal to 1/2 as well. Okay, so I'll make the equality that way. And f defined at 2, okay, is equal to 1/2 as well. Okay, so first things satisfied, the fact that it's continuous. Okay. Secondly, for a slope to be defined at a point, it needs to be continuous, which we've checked for, so that's already checked for. And the slope from the left must equal the slope from the right. So now I have to test for slopes from the left and right. Okay, so if I take a look at actually the function, the one blue function is the 1 over x, and the red function is the linear function, and it looks like this it is continuous at x equals 2 and y equals 1/2. And it looks like it's possible that the slope coming from the right-hand side is matching the slope from the left-hand side. So this is my slope from the left-hand side, and this is my slope in red from the right-hand side. Okay, well, from the right-hand side, we know it's a linear function, so we're going to define that slope as the slope is equal to 1/2. So what we then have to do is then check. So we have to check from the left-hand side. So I'm going to do this in blue. Okay, when x is less than 2, what we're going to do is check for the slope using the slope ratio. So at s, we're going to find the slope, and this is the limit, and we're going to let the h approach 0 from the left-hand side. Okay, and we're going to use a slope ratio. So we're going to go 1 over x plus h minus, it's going to be, 1 over x plus h, 2 plus h, because we know that the coordinate is at 2, minus 1/2. That's going to be y1 minus y2 all over h. So looking at the diagram here, there's my point at 2, okay, and I'm going to choose some arbitrary point that is, let's say it's here, that's going to be my 2 plus h, and I want to find out the slope, so that's going to be, the y-coordinate is going to be 1 over 2 plus h, and I want to know the rise and run between those 2 points as I let h go to 0 from the left-hand side. Okay, so then I can work out this limit. So working out this limit, it's going to be 1 limit as h approaches 0 from the negative side. I'm going to get a common denominator, so I'm going to do 2 minus 2 plus h all over 2 plus h times 2, and then I'm going to put the h in the denominator here. And when things cancel out, we get the limit as h approaches 0, and this is going to be 2 minus 2 minus h over 2 plus h times 2 times h. Those h's cancel out, okay, and I can now do the limit. So we get the limit as h approaches 0 from the negative side, -1 over 4. So my slope coming from the right-hand side, so the left-hand side, is going to be 1 over 4. The slope coming from the other side is going to be, and I made a mistake here, didn't I? The slope is from the linear equation, okay, the slope here of -1/4. Okay, so the slope from the left-hand side equals the slope from the right-hand side. So I'm going to write this here. So the left-hand side was equal to 1/4. The right-hand side was equal to -1/4 as well. And so because the slope from the left-hand side equals the slope from the right-hand side, and the slope is defined at the point as -1/4, this slope does exist at that point, and the slope is 1/4. Sorry, the slope is -1/4.